Hi guys, Audrey here. So today we're going to do some matrix algebra or matrix equations. We are going to solve this matrix equation that we have right here for B. Now, matrix algebra is really similar to regular algebra. So solving matrix equations, not much changes. We do have a few things that we have to think about. We have to think about the fact that we're not allowed to divide. So we have to multiply by inverses instead. We have to think about the fact that the order of multiplication matters. And we have to think about the fact that transposes exist. So we do need to be comfortable with our properties of transposes. For this problem, we're going to make the assumption that A, B, and C are all square matrices, that they're all also invertible. So I can take the inverse of any of them, of any combination of them. I can multiply them together. So basically, we're just making sure that everything is defined. Okay, so let's go. The first thing that we're going to do here is solve this in two different ways, actually. So we'll call this option 1. And it's important to know that, like with regular algebra, there are often many different ways to solve a problem, to solve an equation. So if I'm trying to isolate B here, there's not going to be just one way that I can go about it. So we're going to start with one way and then do another. The first thing I'm going to do here is notice that there are these transposes. So I have the transpose there and the transpose there. And I'm going to use my properties of the transpose to distribute the transpose to the inside. So I'll get A inverse B transpose plus C transpose is equal to A transpose B transpose times C. So here my transpose property that I'm using is that A plus B transpose is equal to A transpose plus B transpose. A transpose is not an exponent. I can actually distribute it to the inside of an addition or a subtraction. Now, the next thing I'm going to use is that I can also distribute transposes inside of multiplication. I just have to make sure to flip the order of the things. Order of multiplication matters. Distributing the transpose, the order must flip. So I'm going to distribute this transpose here, and I'll get B transpose A inverse transpose plus C transpose is equal to B transpose A transpose transpose times C. Now the next thing that we need to know is that A transpose transpose is equal to A. So that's another property of the transpose that we have seen. Now, basically what this is saying is when we transpose something, I take the rows and I make them columns. Well, if I transpose again, I'm taking those columns and I'm making them back rows. So of course I get back to where I started. So we'll use that to get B transpose A inverse transpose plus C transpose is equal to B transpose A C. Okay, so now I have B transpose instead of B. When we're solving equations, oftentimes a good plan is to get the thing that we're solving for all on one side and everything else on the other side. So I'm going to move that B transpose AC to the left side. And I'm going to move that C transpose to the right side. And I'm going to do that just by subtracting. Now, subtraction is a move that we're totally allowed to make. It doesn't change from regular algebra. Addition and subtraction act the same way. So I'll end up with B transpose A inverse transpose minus B transpose A C is equal to negative C transpose. Great. Now, notice that B transpose here is a factor of the left side. We got everything with B transpose to the left side. Now it's a factor. So we're going to factor out that B transpose, giving us B transpose times A inverse transpose minus AC is equal to negative C transpose. Now here, we actually had to be really careful. That B transpose had to be on the left side. So this would not have been the same as saying A inverse transpose minus AC times B transpose. I could not have put B transpose on the right there. B transpose was on the left side of A inverse transpose. It was on the left side of AC. So when I factored it out, it had to stay there. Don't make that mistake. Great. Now, still trying to isolate B transpose, it seems like it would be great to be able to divide by A inverse transpose minus AC, but we can't divide. So instead, when we feel like we want to divide, we multiply by the inverse. So I'm going to do A inverse transpose minus AC inverse. And that's going to have to be on the right side of C over here, because I can only multiply by inverses of things that are on the edge. So I can only stick a matrix on the edge. I have to put it on the right edge so that when I multiply those things together, it becomes I. If I put it on the left side, there's a B transpose stuck in the middle. And I can't just stick matrices in the middle. I can't make I if there's something separating them. So this now has made I. So I have B transpose times I is equal to negative C transpose times A inverse transpose minus AC. Now, remember, when we multiply by I acts exactly like 1. Multiplication by 1 doesn't change anything, so multiplication by I doesn't change anything. I don't need to write it. So now I have B transpose isolated, but that's not what I wanted. I wanted B. So how do we get B from B transpose? Well, I can just take the transpose of both sides. And here we're just remembering the fact here that a transpose is equal to A. I'm doing it to both sides of the equation, so we're all good. So now I get that B is equal to, remember when I distribute a transpose, the order of multiplication changes. So I'll get A inverse transpose minus AC transpose times negative C. And so here, this is because we have negative C transpose, that's just going to give us our negative C. Now this is our final answer. Now we're going to do this problem in another way, just to see that there's another approach that we could have taken to the problem, but the answer is going to look a little bit different. So I'm just going to simplify this real quick to help us see how these answers are going to be the same. And I'm going to simplify this by distributing that transpose. So I just realized that should have an inverse on it. That should have an inverse on it. My bad, guys. This was the inverse of this thing. So there's this other rule that says A inverse transpose is equal to A transpose inverse, which means that I can switch the order. I can do the transpose and then invert, or I can invert and then do the transpose. So in this case, this is like saying A inverse transpose minus AC inverse transpose. I can flip the order of those things. I can say that this is the transpose inside with the inverse outside. So now B is equal to A inverse transpose minus AC transpose, that we're then inverting, times negative C. But now that that transpose is inside, I can use the first property there, A plus B transpose, to distribute my transpose and end up with A inverse minus AC transpose inverse times negative C, which is A inverse minus C transpose A transpose inverse times negative C. So this is just the same answer simplified in a little bit of a different way using this fact right here, that A inverse transpose is equal to A transpose inverse. It doesn't matter which one we do first. Okay, let's do this problem in another way. So when we did the problem in option 1 the first time around, we ended up having to isolate B transpose. We distributed the transposes and we isolated B transpose and then took the transpose of both sides. I can actually avoid having to do that by taking the transpose of both sides first. So I see that as of right now, I don't have B transpose, I just have B. So if I can get rid of those transposes, that would be ideal. And I can get rid of them by taking the transpose of both sides. And when I do that, on the left side, they just cancel out. So I have A inverse B plus C is equal to, Now I'm going to think of this here as two different things. I'm multiplying A transpose B transpose by C. So when I flip the order, my new order is going to be C transpose times A transpose B. And in that case, those transposes are just going to cancel out. The transpose here, right here, will cancel out. That transpose will cancel out with the pink transpose. Now notice, we don't have the transposes with B anymore, and we have B by itself. Now, this has become a pretty straightforward problem. We can just get all our B's on one side and everything else on the other, factor, multiply by the inverse. So A inverse B minus C transpose A transpose B is equal to negative C. All our B's on one side, everything else on the other. Now we factor. A inverse minus C transpose A transpose times B is equal to negative C. Same as before, order matters. This B right here had to be on the right side. It was on the right side of A inverse. It was on the right side of C transpose A transpose. So this does not equal to B times A inverse minus C transpose A transpose. The side that we put B on is important. Now I want to divide, I can't, so I multiply by the inverse. And that inverse needs to be on the left side of my negative C. So over here, I've made I, so I'll have I times B is equal to A inverse minus C transpose A transpose inverse times negative C. And we know that multiplication by I is like multiplication by 1. So this is my final answer. And that was a little bit shorter than the other way. And notice, it's the same. We got the same thing. Yay! All right, that's all. Bye, guys.